In this section, we're going to talk about some aspects of radiation and exposure. So let me bring up our information here so we can take a look at this. So this is section 8.5, radiation hazards. And it's important to note that radiation is invisible. You cannot smell it, you can't taste it, you can't see it. So it is something that you don't really know is happening very often unless someone tells you. Some types of radiation are very, very safe. So for example, magnetic resonance imaging, MRIs, use radio waves, and radio waves are very, very safe as far as we know. But some types of radiation are what we call ionizing, which means that they can eject electrons from matter. And so if someone is exposed to ionizing radiation, the cells in their body can have atoms, have electrons ejected, and that can cause all sorts of biochemical problems or even molecular biology problems with DNA. So you have to be very careful with ionizing radiation. It can be dangerous to our health. Now, there are many different units that are used in radiation. One that's mentioned in your textbook is called the sievert. And the sievert is the amount of any type of radiation that has the same biological effects as those that are produced when you have a kilogram of body tissue, okay, that's absorbing 1 joule of X-rays or gamma rays. So we're using X-rays and gamma rays sort of as the standard. So if a kilogram of body absorbs enough radiation that it's the same amount of energy as a joule or 1 joule of X-rays or gamma rays, that would be called a sievert. There are many different factors that we have to consider when it comes to the exposure of radiation. One is the amount of dosage that you have, how bright is the source. A second is how much of your body is exposed. And then a third would be the amount of time that you're being exposed. Now, some problems with radiation, ionizing radiation, is that it can take years to have the effects present themselves. So you could be exposed 1 day or 1 week and not really know anything, not experience anything for even years, okay? And that makes it hard to determine causation. So if you suffer from cancer or leukemia, or you have offspring with birth defects, if the exposure was years ago, you can't really determine whether that exposure was the cause, or it could have been some other effect, genetic or some other exposure, chemical exposure later on. Furthermore, the effects tend to be statistical. So individuals have different expressions of exposure. So if you expose 100 people to the same amount of radiation, maybe only 5 or 10 of those individuals will have effects that are visible and you can determine. So it's hard to tell what the effects of the radiation are. Now, there are different sources of exposure. We should be aware that we're exposed to radiation all the time, and a lot of it's actually natural. Much of the natural exposure we get is due to radon, and that depends very much where you live. So in areas where there's a lot of granite, and if you have a basement over a granite ground, the basement will have can have very high levels of radon. So it's regional, depends where in the world you are. But we do have a lot of natural exposure. So even the buildings are made out of rocks and plastics and things like that. There's a certain amount of natural radiation that occurs. So if you look here, radon is a source coming from the ground. Gamma rays can come from the ground or from buildings. We also have cosmic rays that come from events that are occurring outside our solar system. And but there are medical issues that can arise. So for example, 16% here is what we call artificial. People do have medical tests done on them that expose them very often to X-rays. Okay. So here's some examples of X-rays that you might be exposed to. What I've done is I've broken it up into here, the type of diagnostic test you're getting, and then how much exposure you have. And one of the things that stands out, your textbook actually has a few paragraphs about this, is the amount of exposure you get from CT scans is much greater than it is from other types of diagnostics. So a pelvis, for example, a pelvis CT scan has 10 millisieverts, so it's a thousandth of a sievert. Chest CAT scan has 7, and the head CAT scan has 2. When you look at other types of x-rays, like the abdominal x-ray or a mammogram or chest x-ray or a dental x-ray, they're much smaller numbers. So your textbook really does talk quite about, the author talks about how California has actually made some limits in terms of using CT scans for routine events. So, obviously, if someone has a serious injury or a serious condition, then it might be warranted to do these CT scans. But for routine scans, it's probably not a good idea, because again, it does tend to be additive, and the intensity of the beam used in CT scans is very high, and you're exposed for a relatively long period of time as well. So be aware of that as you start to think about the idea of radiation.